Hi everyone and welcome back. So because we in the last video we discussed the function, so I'm just going to discuss one additional concept related to the function, and that is recursion, which is very important because we use recursion especially once we traverse the data structures like tree or graph, because that's where it comes into the picture. And it's a very powerful technique to reverse the structure which has the nested implementation naturally in place. So what does it mean? So for example, if I just take an example of the rectangle, and in that rectangle, let me just reduce it. Yeah, in that rectangle, I'm just going to create another rectangle, which is obviously subset of it. And then let me just put it in place inside, and then I'm going to have another rectangle, and let me just change the color to a little bit different. Yeah, let me just put it inside. So now you can see in here. Sorry, I need to change it as well. Yeah, I think that's much better. Yeah, that's much better. All right, so what does recursion do? It actually call your function, and then based on some condition, it will recall the function during the execution. So for example, if I'm just calling so for example, the external rectangle is my function. So what it's going to do, once it execute, it's going to call the instance of the same function with maybe some different set of parameter, and then from there it won't finish its execution. What it does, it actually leave the execution of the outer function, and it start executing the functionality of the same function but with different values, right? And then it will come to the deeper level, right? So that's how we actually get the solution, that we go all the way till we reach to one particular condition, and then we start traversing back, and that's the whole concept of the tree. So if I quickly draw the tree as well, so that's also going to help you to understand. So for example, I have a tree like this, and you can see it has the child nodes and the parent nodes. So what's going to happen, let me just connect all these two for the sake of understanding. I have the dynamic connector or just a line? Okay, so I think that's no, that's not the line. How about, let's use the arrow. I can change the arrow later on. All right, so you're gonna see, yeah, I'm connecting it in here. Okay, need to connect to here, and then again I'm going to connect in here. I'm going to connect it in here, and so with the other two, right? So you can see, so once I start processing my tree, so for example, that's the node A, that's child node A1, and that's child node A2, and we can call it 1, and we can call it 1, 2. Here we can call it 2, 1, and respectively, right? So once we call our recursive function, it's going to actually process this node, and maybe at before even we completing the processing, we want to go to the next level. We're going to go to the child node, and then on the child node, before we finish the processing, we're going to go towards the grandchild node, and then all the way to the deeper level till we reach to the point where we don't have any child, or even a particular condition has been met. So we start traversing it back. So we're going to finish the processing. So once it's finished the processing, it finished in the reverse direction. So let me quickly show you the flow. The flow for starting the processing is in this direction. So you can see, let me see if I can line. That doesn't look good. I need an arrow, so that will be much better. So what I'll do, let me just draw the arrow. I think that's much better. Yeah. So once the function start execution is from top to down in this fashion. But once we finish it off and we actually complete it, I'm just gonna reverse this. Hopefully I can do it. Let me see. Yeah. Let me just adjust. So the execution completion is going to be, so that's the calling. Let me just call it calling, and that's the completion. Now, what does it mean? So, for example, let's take example. We want to calculate the sum of a series, right? So the number is starting. Where's the text box? That's the text box. Yeah. So number starting from 1 all the way to, let's say, 1000, right? So what I'm going to do, I'm just going to actually now put a condition that, okay, if we reach to the last number, then the function keep going till we not reach to the last function, till the function call itself, until unless we reach to the last function, right? And as soon as we reach to the last number, which is the maximum one, then we start adding the value to the total value, right? So how it's gonna look like, so for example, in the first part, it's gonna look at the number which is starting from 1. It is not equal to the maximum number, so it's not gonna do anything because the condition has not been met. So it's going to actually call the same function, but this time we need the next number. So we're going to do an increment into the function. So it's going to be the first call with 1. The second call will be with 2 because we are incrementing, and we're going to just see practically in a moment, right? So the next one is going to be obviously 3 till we reach to the next one is going to be 3, right? And then we're going to be have 4, 5 all the way till it reached to the number 1000. As soon as it reached to the 1000, all right, and we call the function again for the 1001, it's going to actually check the condition. Now the 1001 is greater than the 1000, right? So it's going to terminate that recursion and it start completing the call and start traversing back to the towards the initial calls, right? So it's come back and it's gonna see, okay, what I'm gonna do with the 1000. We know we're gonna actually add it into some sort of summation, and we're gonna return it. So what it will do, it will add the information and it return, right? And where it return, it's gonna actually return to the previous iteration, which is going to be 999. So what it's gonna do, it's gonna say what value it is returning. Whatever value is, it's going to add it into the previous value, and then the cycle goes all the way till the first one. So very powerful concept, and that's just the example. We can process any sort of processing at any node, right? So that's really powerful concept of recursion that we generally use into our solution, right? So let's see how we can implement it. So what I'm going to do, let's do it in a new file, and I'm going to call it, okay, it's saying, yeah, it is ready for me to save. So I'm just going to recursion demo UI. All right, so what I'm going to do now, I'm just going to import, I don't think I need any import. So I'm going to start the summation, right? So I'm going to calculate the summation, and I need a number. So I'm just going to get the number. And now here, the first step, you need to define the ending condition. So what I'm going to say, if number Okay, what I can do, let me quickly think. I don't want to add an additional variable. I'm just thinking, can I hmm. Yeah, I think if I want to go towards the end, I need to define another variable. How about if we come in the reverse direction? So what I'm going to do, instead of starting from one and going there, let's do backtrack. So what I'm going to do, I'm just going to put a condition till my number is, if it's less than equal to one, that's my terminating condition, return one, right? Because I don't want to process my recursion any further as soon as I reach to the point of one, right? So which is fine. So now what I'm going to do, okay, as long as this condition is not true, what I'm going to do? So what I'm going to do now, because my value is in the num and I want to add it to the series, but I don't have the sum of the series. So you can imagine, so we have 1 plus 2 plus 3 plus 4 all the way plus n, right? So if I have, for example, and I'm sending this, so instead of n, how about if I just say yeah? So I'm sending 1,000 to my function. Now this 1,000 is going to decrement one by one, and what's going to happen? All I need to do, I need the sum, which is obviously from 999 all the way 1, so I can add it into 1,000. Now this 1,000 has been stored into my num value, right, which is in here, right? So in order to calculate for the rest of the summation, I'm just gonna do, okay, summation of, but now get the summation of num minus 1, right? So what it does, it will call the same function, but this time what it will do, it will do it for 999 in the next round, right? So in the next round, it's gonna again, and imagine the processing hasn't been completed yet, right? I also need to do the return because we are returning the value, right? So what's going to happen? It's going to call the function with one less, which is obviously 999, and then again, but this time it's going to be 998 all the way till it reach to 1, right? So now as soon as it reach to 1, instead of executing the else part, the function is going to execute the return, the if part, because our first if condition is now returning us true, because the value of num is equal to 1, not less than, but equal to 1. So it's gonna give us true. So now from here, it's gonna return, right? But on the above, we have 1 plus 2, right? And we call it with 1 plus 2. And now whatever value it's gonna return me from the 1, we're gonna substitute it. So which is going to be 1. So 1 plus 2 is going to be 3. So it's going to be 1 plus 2 plus 3, right? So this part is going to be substitute with 3, right? And 3 plus 3 is going to 6 all the way. You start calculating the total for this function, right? So till it reached to our first call, right? So the same concept, the only thing we are doing it in the reverse order. I just want to save one parameter. That's the only reason. Okay, so now let me see if I can call the summation, and I'm going to call it print summation for example, let's do it for 10, right? And we'll see what's gonna return. So 55, which looks good to me. So how about we just calculate it? So 1 plus 2, 3, 3 plus 3, 6, 4, 10, 15, 15, 6, 6, 21, 21 plus 7, 28, 28 plus 8, 36, 36 plus 9, 45, and 45 plus 10, 55. So you can see we have the 55, which is returning on your prompt, right? Which is pretty powerful, right? And you can see it's pretty fast now. How about if we do for 1000? Oops. So now you can see it's complaining that the maximum recursion depth has been exceeded while it is calling the Python. So that means we obviously have a limit. So if we cannot cross that limit, how about if we do the summation of 100? Can we do a recursive call for 100? Yeah, we can do it, right? So even you can split it into chunks, and then you can do the recursive function. So for example, I know that the summation of 1000 is not possible, but how about if I just do, let's see if I can do for 500. Is it does it afford 500 call? Yeah, it can afford 500 call. How about if I just do, from 500 plus 500? And now I'll have a look how I'm going to actually outsmart this condition. So I'm just going to call it, let me just do nation. So I'm just putting a range. So num A, comma, num B. So the only thing I'm now changing is I'm instead of calling from the highest value, now it gives me the option. I can go from start to end or end to towards the start, right? So now I can actually say if num A is greater than num B, right? Then just return num A, right? Because I just want to see whether it's going I don't want to edit, I just want to return. So because that's the indicator that, okay, our condition is finished, right? So for example, what does it mean? So we are going from, we are summing from 1 to 10. And as soon as we reach to 10, or we are going and range will be 11. So what it's going to do, it's going to find out, okay, the condition is terminated. So it's going to actually return us the num A, right? Which is obviously, sorry, it's going to, we're going to return num B, because that's where we reach to the end condition. And now we can start reversing back, and we can start adding the summation, right? And if we are not reaching to that condition, that's pretty simple. What I'm going to do, whatever value I do have. So for example, I do have a value in my num A, because I'm continuously, so in the first range, I'm going to run from 1 to 10. In the second range, I'm going to do from 2 to 10. In the third range, I'm going to do 3 to 10. So you can see my my initial value is changing. So I'm just using my initial value to add whatever return from the summation, R summation, which is the range summation, right? And because I'm now going towards the from start towards the end, so instead of num, I'm just going to say, yeah, add instead of -1 to +1, right? So let's test it before we run it for a complicated one. Let's test it for our summation, right? And now we are going to do, because we want to do 1 to 10, let's comment this. And if I just, now if I run it, so we'll see whether we're going to get the same result or not. So it's going to say, I'm missing a parameter. So it's going to be num b. It's expecting two parameter, but I'm just sending one parameter, which is fine. I can fix that issue. How about now? Should we have 55? Okay, there is some logical error. Let's see where we have this error. So what we are doing, it is returning num b, which is 10. Okay, we are calling here num a is greater than 1. Oh, sorry. It's going to num b. I didn't complete my condition. So because we were using the previous, we copied the previous function, so there was a logical error. So if I fix now, let's see how about now. 65, right? So that means there is an additional value that has been added. So let me see where it is adding. It shouldn't. And how about if we say that's the right condition, and I'll explain. Yeah, now we are good. So let me explain. Just there is an additional iteration because I think we need to terminate our condition as soon as we reach towards our last iteration. So if we are going from 1 to 10, as soon as my initial value is equivalent to my maximum value, that means that's the indicator I need to terminate the condition because we are already reaching towards the end of the series, right? So you can see now I can in here, as soon as the value of num a, the first value is going to be equivalent to num b, that means that's the last iteration. We need to start traversing back, right? So that's why I'm returning the num b, which is obviously this guy 10, and then it will substitute that value in here. And then in the previous iteration, we have 9 in the num a, so it's going to add 10 into 9, and then this cycle continue all the way till it reaches towards the first iteration, right? So which is now giving us the right result. Now, just on the confirmation perspective, that both functions are producing the right information. So I'm just going to say this one is going to be simple recur and because we are just going one direction, but in the other one we have a range, so that's going to be, I would say, advanced recursion, because in here I can do now. But now you're gonna see both will give us the same results. Yeah, both are giving us the same result. But just to end one more test, what we're gonna do, for example, 20 and 1 to 20. And run it again to see whether it's going to give us the, yeah, both are, so which is good, like we are getting the same result. But now the test is in here. So I'm just going to, because I know I cannot run till 1000 because it won't allow me the that. But what I can do, I know I can go from 1 to 500, and then from 500 1 to 1000, right? So let's see whether it's going to give me my required results. Yeah, 500 500. Now I'm going to check my result, that whether they are valid or not. I will show you a technique in the next video, that how you can validate your recursion is correct or not. Sometimes it's complicated to put the validator, but obviously there's a way that we can implement the logic without recursion as well. So if you have any question in this video, feel free to reach out, put your comments, happy to answer. Otherwise, thanks for watching and stay tuned for the next one.